our dynamic drag reels with the electric reel project. So some of the problems that our client gave us was limitations in existing reels, which includes line length measurement and inaccurate or imprecise feedback in the drag set. This is mainly involved with the fact that rotations are 1-to-1 on electric reels right now, where say one rotation is 1 foot, which doesn't allow for an accurate line measurement as you get out further. Not having a drag set can cost you your fish, as certain species require certain strength on the line, or you can pull the hook out of its mouth. And as of today, there is no reel that can display the metal line, or drag strength on the line. Also, there is no reel out that has a fish detection system on it. High cost limits accessibility to other people with reels that we built costing up to about $9,000. The reel that we have cost about $1,000 we got gifted, not in the budget. And physical and usability requirements. Holding a reel going deep drops can actually leave a lot of bruises on your body, a couple hours throughout the day. No one wants to do that. This is a hands-off reel. So the solution we have a real-time display of drag and line length, with the line length using a equation that actually takes into account the diameter of the spool changing as the length goes out. And the drag is resettable, so you can actually test it upon buying the reel, set it using your scale, and then forget about it, and if it ever goes off, you have the settings where you can alter that value. Wireless control of a mobile device, which you can actually control all of the functions on the reel for up to a minimum of 33 feet away on the boat. And a fish alarm that you can toggle on and off with the mobile device as well, let you know if there's a fish on the line. So criteria given by our client, he wanted a 12-volt system, so running off a 12-volt battery, variable retrievable speed, have a line length with an accuracy of 15 feet at 200 feet, and a drag strength that is within 5 pounds at each of the positions. Recalibration options within the settings for the line and drag system. Visual display that you can see with polarized glasses out in the sun, a fish alarm, and also be able to control from a mobile device at a minimum of 33 feet away.
With these criteria, we were able to make our main objective, which was to create a user-friendly electronic fishing reel that has the capability to display drag and line length, and also having a mobile device that can be controlled wirelessly. We also took the criteria and we made 5 separate modules that were separated for each of our teammates. So I will be giving them off by their own module, starting with Jerson.
Hello y'all, my name is Jerson Benavidez, and I was in charge of the power management module. And basically my module had to provide reliable and steady power to all the components of the reel, and I was also in charge of providing variable power to the motor.
For my module, I was in charge of creating the mobile device for the electronic reel. The mobile device had to display the line length and also the drag, and it also had to have various functions. 2 important functions is the reel up and the mute buttons that you will later see, and also a settings menu to change other features.
So my module was the line and drag, so I had to be able to read the rotations within an accuracy of 15 feet at 200 feet for the line, as well as, like I said earlier, within 5 feet for the drag in each position. Also the settings menu that is able to recalibrate the line and drag settings.
So for my module, I was in charge of the user interface, and for the user interface, we wanted a screen that was readable with polarized glasses, that was capable of being able to display the line length as well as the drag set. And I wanted it to be readable, so I went with a larger screen as well. One of the main things as well is we wanted to have an alarm that alerted the user whenever there's a fish on. So we went with a buzzer, just a constant tone, just to alert the user. Feature we made, adjust that to some sort of distinct noise, depending. And we also wanted an interactive keypad that wasn't, too complicated for the user to understand and use. So it's fairly simple, and it only features a few inputs, which have multiple different functionalities.
My module was the microcontroller and communications portion. I was in charge of making sure everyone's sensor data got to everyone else's UI modules or power modules and things like that. My main focus was focusing on making sure the mobile device could connect to the main reel from at least 33 feet out, which is the length of the boat that our client was using. Of course, we tested up to around 140 feet and still had good work with that. I was also working on making sure that we had at least every single sensor reporting back at least 5 times a second, and screens refreshing 5 times a second as well, along with at least 100 or most 100 milliseconds of ping to the mobile device in the main reel.
For the system architecture, we had a microcontroller that processes all inputs. We use the main reel Pico as a server, so that will store all information and send necessary information wirelessly to the mobile device. It'll store any information that's not currently being used in case it needs to be used at some point in time. And there's power supplied to almost all the components from the 12-volt battery or the battery on the mobile device. The only component that is powered separately is the potentiometer for variable speed, and that is powered directly from the Pico itself.
So for the data flow of our project, basically all data will pass through every single module in some way. For example, let's look at the line length. So in the drag set line length module, the line length encoder is going to send pulses to the microcontroller, which is then calculated into a line length calculation. That will be passed to a few places, specifically first the UI, that will be displayed on the screen for the user to actually read and how much feet or meters their line is out. That's going to be passed to the power system as well. Say for example, the line length is a value that is equal to or less than the auto stop length. The motor will then stop so that way you don't accidentally yank your fish out of the water and over the boat or in the boat with you. Then that line length value is also going to be sent by a Bluetooth LE to the mobile device, where it will also be displayed on the screen on the Bluetooth, or on the screen, over Bluetooth to the screen. But the mobile device can also send values back, like a reel command, along with changing the metric to imperial systems or any other systems like that.
The main reel. So our base of our project was the Crystal XL621 reel, and we added features such as variable speed to the motor, interactive user interface, sensors that read the drag and line, as well as LCD screen that is readable using polarized glasses.
And then for the mobile device, we went with Bluetooth to connect it wirelessly for that bidirectional updates. And also, if you see on the top of the screen, that's where you would be, it would display the line and drag. And it would also have icons on the very top of the screen that would give you some heads up on if the reel up button is pressed, and also the battery indication for how much battery life it is. Also, there's ways that we try to make it more water resistant, since it will be in marine environments. You can kind of see on the middle of it, there's a gasket and also a little plug on the left side. That's made out of a flexible filament for 3D printing to make it, a little more tightly sealed. And lastly, we have it can also be read with polarized glasses.
So currently, our project is fully functional. It's fully integrated. Everything works communicating between each other. We're still currently working on finishing up our water resistant. So we want to make sure it's water resistant, so that way, you're going to be on a boat. You don't want any water to mess up any electronics. So we did have setbacks with that. Some of the main things was our Pico had actually shorted out, so we had to actually go and resolder all of that stuff, make sure everything's working properly. Part of that is making sure that the Bluetooth will actually send correctly to the mobile device. Another thing was 3D printing. We ran out of filament doing our prints, so we had to make sure we can order more filament to continue our prints. Some of the milestones you see at the bottom is we did get second place at Excellence Day. We do have a fully functional reel and mobile device system. And then the wireless connection actually reaches beyond 33 feet. I think we were able to get it closer to 140 feet. And then we have completed our demo for it.
So this is the budget. We were allotted a budget of $1,000. We stayed well within our budget with all the add-ons, just taking up just a little over $700. And if you include the reel, we do go over budget, but since it was sponsored, we didn't include that within it, so we just left that out. We ignore that. And then expenditure summary. So every engineer was compensated with different wages based off of experience and roles they played. We also included a 5K benefits package along with each position, as well as a 25% overhead just in case, you never want to go over your budget.
Thank you. And a quick conclusion is basically our achievements. We were able to demonstrate a fully functional reel and mobile device. Our budget, we were able to be under the $1,000 limit. And lastly, our future work is just finalizing everything, making sure everything's water resistant, and making little tweaks in the code just to make everything smooth. That's it. Thank you.
Any questions?
Questions?
So, the pole vault battery system, did you ever test it at rated voltages, 11, 10.5?
To answer your question, no, we did not. We just got a 12-volt marine cycle battery, and it's basically a big old car battery, and it pretty much just stayed at that steady, like nominally at 11.9, roughly 12. So it didn't really vary too far from that. We also do not pull too much power. Any other questions?
Was there any consideration to like the salt from the sea or ocean eroding it?
Yes, that's why there's gaskets on everything. The one thing we could not find that was stainless is the potentiometer, so that is gonna be something that's gonna be found a little bit in depth, but Amazon did not have it at the time, so. Any other questions?
So are you planning on testing the scan or reel?
Yes, so, mahi season is starting up and our client wants to try trolling with it, which it's not really made for. Mainly made for deeper drops, but he just wants to go out on the boat and actually use it, so within the next month, we plan on actually going out and having a real world test with it. So that'll be fun. Oh yeah, and Crystal, we are supposed to get in contact after we are done with our course to talk to them about this actually as an add-on feature. So hopefully that goes good.
What changes in the architecture could you imagine if this went into a production type environment in terms of would you still use a Pico or would you use a different embedded microcontroller and in terms of the rest of your architecture, what might change running it into, we're now making 500 of these instead of one?
That's a really good question. So for our embedded system, I feel like we would definitely choose a different approach just because I feel like we could get away with less pins on the actual main reel. The mobile device, we really were able to manage to use every single pin on that Pico. But other than that, at first we thought that the mobile device was going to be a very integrated, like not an add-on way of doing, the reel was not going to be like an add-on feature. But then after we were going through the semester, we realized that it'd be a lot easier in the world of like business too to creating an add-on thing rather than just implementing into one reel. So the only part of the reel that is actually inside of it that we added on was the H-bridge, converting that 12 volt to and the voltage regulator, which goes down to 12 volts to make it the power of the Pico. But other than that, everything else is just added on there. And if we were going to change anything, it would just be that casing around it, just make it a little bit nicer and sturdier.
So as of right now, if you have a standard electric reel that's powered by 12 volts, you can snip the leads off and this will theoretically plug into that and work with that. So like you were saying, just change the case to make it fit and it should work.
So I understand that you are using a DC motor on the wheel, right? Yeah. So do you think it would be better if you use like a, I don't know, let's say a permanent magnetic synchronous motor with an inverter? Would it prolong the life of the reel because the DC motor has brushes and all that stuff?
I'm I'm sorry, I don't think I fully understood your question.
So my question is, your reel is using a DC motor, right?
Yes,
The
sir.
DC motors have brushes, so they'll have a limited life.
Yes.
So would you consider using a permanent magnet synchronous motor with a small inverter or something like that?
So an important thing to mention is that the reel that we have is not, we didn't add on the motor itself. So the motor itself came with the reel. That's how it is, electric. So we wouldn't really want to change that because then that would just go more so into implementing the actual reel itself and not making it able to go on different reels. So that's why we wanted to stick in the add-on side of things. But great question.
Okay, thank you.
What would you say that was the most difficult part of completing the project?
So I'm not sure if it's just because we're towards the end, so this is the most recent problem. But I definitely think housing was one of our struggles, is trying to get everything nice and tidy, trying to go with the curves of the reel, or for the mobile device, making it very compact. Also, for the mobile device, I was trying to do resin coating on it, and it was not fun. Let's just say that. I had to sand it basically all off. But just honestly, I think that's the biggest issue we've gone through.
Everybody agree?
Yeah.
Also, changing from the housings that we've had to do, in and out, the solder does not like to hold on to the connection, so right now the buttons on the reel are reversed because we had to do it last second, so left is right, right is left. We didn't mention that during the testing, but. No, not testing, demonstration. Everybody? Thank you all.
All right, thank you.